So what I'm about to show you is quite advanced, and well, to do it what you'll need is full the CLL, and so you're going to need, you know, the two parallel algorithms, so this one, and also the diagonal swaps, and you also need to be able to, you know, instead of getting a parallel, just solve everything in one algorithm using CLL. So that's all the basic knowledge you need. Now, learning the Eg method can be quite difficult, and it can be tempting just to stick with CLL and see if you can get fast with it, but it is okay. I'm not going to do very difficult things yet. So Eg will take any face, and you just use one algorithm after you make a face just to finish everything. Now in this case you could do Ortega, it'll give you a bar in the back. CLL you probably shouldn't do, because that would put the bar, that would just solve this, and you'd have to flip over and do diagonal swap. And so here I'm going to show you how you can take this same, just use a CLL algorithm and turn it into an Eg2 case. And so the only reason I'm calling this advanced is because you need to know CLL for it. But if you know CLL, that's the exact same case. Should easily be able to do it. Okay, so background information: the Ortega method will just take two faces and then use the permutation of the rest of the pieces to find an algorithm for the rest. And if you didn't know, this is one of the cases. This is a diagonal swap on both, and this can be from any angle. You'll just do, normally from this angle you'll do R2, F2, R2, and that will solve both, or R2, B2, R2. Both are fairly good, depending on which angle you're at, or like, yeah, where you've just finished your face. Sometimes it'll be easier to just do R2 in a certain direction, and so that's why you can do both. So I'm gonna set up for a case right now. So this is an H case. Now the CLL case for this is very easy, goes like that, but of course that would solve it. And this is going to be my example. What we're recognising, and I'll get my other 2x2 quickly. Right, so pretty much we know CLL recognition already, and we know that this is the pure 5-move case here, where you do this 5-move algorithm which just finishes everything. And since we know the recognition, we know that it's because of these two bars. Okay, so okay, that was a mistake on my behalf. So this case, now if we do it, since the bars are horizontal, and so these normally would be the same, now they're opposite, and so it's just the complete opposite of the case. We're going to get diagonal swap. So, knowing that, we can just do the case and then do the diagonal swap. But the best thing about Anticll is in every single case you can always cancel a move, and I'll explain why. But firstly I'll show you. You'll do the 4 moves of the algorithm, and then you'll just add F2 or B2, and then finish with the R2, and it completes it. And this can be done for any case. You just need to be able to figure out how to, know which case to do, and that will come with time. I'm going to create a diagonal face somehow. Okay, I'll just create a bad layer, and then So we got a diagonal face here, and so we're looking at the corner permutation and orientation. So there were 6 L cases, and what we know for this is for L there are 2 where these are the same, 2 where these are opposite, and 2 where these are adjacent. When they're adjacent, we know that we can decide the opposite by these colours corresponding. So if these were, since this is the pure corners case, we know that we've got to do the diagonal CP case. And so if we were to do a diagonal swap algorithm and just twist our corners into that case, we get this case, which is sort of like that. And so, since that's the opposite, I'll just do it. And instead of going down like this, I'll just cancel into the permutation like that. And you can try this yourself. It's just cancelling into R2, F2, R2, or R2, B2, R2, and it will solve the case. So the reason you can always cancel a move is because not only does R2, F2, R2 work, but F2, R2, F2 will also work. And the algorithms will always end in R, L, F, or B. And that is because you never at all use D for an algorithm in 2x2, and U is just AUF. And so it's not at the end of an algorithm because it depends on where you started the algorithm for, meaning it will always end in this, 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 or this. In which case, if it's here, you just do this or that. Same result. And so therefore, you will always be able to cancel into one. And so if I were to get up CS timer, and I'll just go to a new session, and then in the 2x2 subset there's an Eg2. And so we see here, we've got, oh, okay, so this is the case I just showed you. Recognise that these are the same and these are the same, so it's pure corners. And so we'll just do this one, cancel into it. Okay, so for the standard T-case algorithm, and this is the standard T-case algorithm, we realise that these two are the same and these two are opposite. But then again, from this angle, if you were to do it on the left, you'd just get this whole thing, but diagonal CP. And that's what the CLL is for this case, or at least the one I used. And so if I do this, I can then finish it with F prime instead, and then do R2, F2 to finish it. Wait, let's do another one. Okay, so this is the thing for L cases, and I'll have to show you. So there are ones where they are opposite like this, and ones where they're the same. So if I get this up, and then I'll do like so here's an example of when they're the same. Here's an example when they're opposite. And so, since what we're really recognising is this colour here, and if it's opposite to this, or opposite to this, or the same as this. Okay, if it's opposite to adjacent to these. If it's adjacent, like it could be, imagine this mirrored, but just, yeah, then we do the algorithm for this case. But if it's opposite one, we'll do the corresponding algorithm to this. So for this one we do this CLL, and for this one we do this CLL. So the CLL for this goes F2, R2, finish it. So the one for this goes like this. Cancel into it. And so I'll keep doing more examples. Okay, so for this one we notice these are the same and these are opposite, and so we're going to instead do the one where these are the same and these are opposite, and so we'll visualise that in our head, and then the algorithm is, but we'll finish it with an R prime and cancel. And if it's hard to figure out how to cancel and it's faster for you just to finish the algorithm as normal, that's perfectly acceptable. Oh, this is my bad one. So these are opposite and these are opposite, and so we'll just treat them as if they're the same. Finish with an R prime to cancel into it. And so here's the rule. So if they're the same, treat them as if they're opposite. If they're opposite, treat them as if they're the same. And I've done that wrong. And if they're adjacent, they'll still be adjacent. So we got that and then finish. And for this one, yeah, it's just that and then finish it. So that is how to do Eg2 intuitively. And so if you learn Eg1, you'll effectively be able to solve anything from any face. It might take a bit more recognition, but you'll get used to it, just like you get used to CLO. And many of the Eg2 algorithms, like, for example, this Eg2 case is actually just an anti-CLO, and a lot of them are like that because they're so easy to remember, and sometimes they're only adding one move to the algorithm. And so that's how you do Eg2 intuitively.